screen with you. All right. So just like yesterday, I'm gonna you'll have these examples next to your classwork so you can look at them if you need to. If you're working on the classwork and you forgot how to do something, you can look at these examples. I'm also screen recording this too, but it takes usually 10-15 minutes to get it uploaded onto the YouTube playlist. So number one, we've had a similar problem yesterday with just different numbers. A cooler contains 13 bottles of sports drink, 4 lemon lime flavored, 5 orange flavored, and 4 fruit punch flavored. So 4 plus 5 plus 4, that's 13. You randomly grab a bottle, then you return the bottle to the cooler, you mix up the bottles, and you select another bottle. All right? We want to know what's the probability we get lemon lime both times. Now, because we put the bottle back after we picked the first one, these two events are independent. If I start off with 4 out of the 13 bottles are lemon lime. So if I take one and put it back, I still have 4 out of the 13 that are lemon lime. All right? So my probability of getting lemon lime both times is going to be 4 divided by 13 times 4 divided by 13. Do we understand where I'm getting those numbers from or no?
Nope.
Okay. There are 13 total bottles, right? In fact, let me use the highlighter.
Yeah.
All right, there's 13 total bottles, and there's 4 lemon lime. So every time I reach in to pick one, if I want to get lemon lime, I've got a 4 out of 13 chance.
Okay.
Okay? And I'm doing 2 picks, so I'm going to multiply the 2 probabilities. All right? And I want to remind you, I gave you a link yesterday, and I included the link in today's classwork. If you'd like to use a calculator, go to the link, 4/13 times 4/13. And if you go click over here on this little fraction button, it'll give you the answer as a fraction. 16 over 169. So if you want me to mark you right, I want to see how you got the answer and the answer. I want to see something times something and then the final answer. Okay?
Okay.
All right, number 2. We're doing 2 things again. I'm flipping a coin and then I roll a dice. All right? And I want to know what's the probability of heads and an even number on the die. Okay? So let's just take it one thing at a time. When I flip a coin, what's the probability of flipping a heads?
1.
1 out of
2.
2. All right? Times. And when I roll a dice, what's the probability of getting an even number?
3 out of 6.
3 out of 6. Very good. There's 3 even numbers, 2, 4, and 6, out of 6 possible answers. 3 out of 6. Okay? And again, you can go here 1/2 times 3/6. Clear all. 1/2 times 3/6, and turn it into a fraction. It's 1/4 when you reduce it. All right, it's really 3 over 12, but it reduces to 1/4. Questions on this one or no? All right, number 1 and number 2 are what we called independent experiments. When I flip a coin, it doesn't affect what happens when I roll the dice. Number 1, when I take a bottle and put it back, because I put the bottle back, I have the same chance of picking lemon lime the second time than I do of picking lemon lime the first time. Number 3 and number 4 are different. All right? These are going to be dependent events. And hopefully I'll do a good job of explaining why. Number 3, we've got a bag with 5 red marbles and 6 blue marbles. All right? So we've got 11 marbles, right?
Yeah.
Right? We've got 5 red and 6 blue. All right. Now I want to know, I want to pick a marble and then pick a second marble, but it says right here, I do not return the marbles to the bag. Do you see that? When I take a first marble out, I do not return the marble to the bag. So whatever I get the first pick affects what I can get on the second pick. All right, so the first time I pick, what's my probability of getting a red marble?
5/11.
Good, 5 out of 11. All right, but now I want my second marble to be red. And let's say I did get a red the first time, but I didn't put it back. So if I didn't put that red marble back, now I've only got 10 marbles in the bag, and I took a red out, so now there's only 4 red marbles left. So what's my probability of getting a red marble on my second pick?
4/10.
4 out of 10, that's right. All right, so that is going to be 5 out of 11 times 4/10. That's going to be 2 11ths. All right, when we reduce. All right, 5 out of 11 times 4/10. Go over here, turn it into a fraction, 2 11ths. All right, let's do another one where we have what is called dependent events. I've got a box of chocolates. We've got 5 milk chocolates and 7 dark chocolates. So overall, I've got 11 chocolates. I've got 5 milk chocolate and 7 dark chocolate. All right, I randomly pick a chocolate and eat it. Then I randomly pick another piece. And it does not say I put the first one back. If you don't put the first one back, then you have what's called dependent events. Whatever you pick the second time depends, your chances of what you get the second time depends on what you got the first time. So I want to get both pieces are milk chocolate. So first of all, what's the chance that I'm going to get milk chocolate the first pick?
5 out of 11.
Good, 5 out of 11. All right, and now let's say I did get milk chocolate the first time. Well, and I didn't put it back. So now there's only 10 chocolates left in the bag or the box, and now there's only 4 milk chocolates left. So really it's the same numbers as the last problem. All right, now there's only 4 milk chocolates left out of 10 total chocolates in the box. How do people feel about 3 and 4? Do we understand them or not so sure?
Not so sure.
Okay. All right. Is that Magina? Was that Magina talking?
Yeah.
Okay. So let me all right, let me try a different screen share for a minute. All right. Let's all right, first of all, let me okay. So let's say I've got in a bag, right? A bag has 4 black, 3 red, and 2 blue marbles. Okay? I want to know what's the probability that I get black and then blue. All right? But the key is I'm not going to put the first marble back after I take it out.
Uh-huh.
So how many marbles do I have altogether?
9.
9, right. So my probability of getting black the first time is 4 out of 9.
Mm-hmm.
But let's say I was lucky, I got the black one that I'm looking for. Well, so now there's only 3 black marbles left. And now there's only 3 plus 3 plus 2. Now there's only 8 marbles left in the bag. Now, what's my probability of getting blue the second time?
2.
2 out of, now there's only 8 marbles left in the bag, right? So that's 8 out of 72, which is 1/9.
Can I ask you a question?
Yeah, of course.
Why when you get the black one and you have a 2 and you have a 2 and plus the 4? Like you said, 3 black. No.
Yeah, because this time I'm not putting the first marble back in the bag.
Okay.
All right, so I'm picking 2 marbles, and the first one I get out and it's black, and I don't put it back in the bag. So there used to be 4 black marbles, but after I take one out, now there's only 3. Does that make it?
Oh, okay.
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 All right, and that's really the main idea here that's new today. All right, let's go back to these problems. So on your classwork and on your homework, the first 2, you are putting the thing back. Number 3 and number 4, you're not putting the thing back. And after that, the last 4, you have to figure it out for yourself. So number 5, I've got 4 white socks, 4 brown socks, and 4 black socks. So first of all, I've got 12 socks. All right, 4 brown, 4 black, and 4 white. Okay. I randomly picked 2 socks. Does it say that I put them back? Does it say when I picked the first one I put it back? What do you think, Anastasia? Does it sound like I just take 2 socks out and don't put them back, or does it sound like I take one and put it back and then take another one?
The second one.
Okay, so I want you to. I'm glad you said that because I want you to pay attention. If you do put it back, you'll see language in there. Like look at number 1. You'll see something like this. It says, "Then you return the bottle to the cooler." Okay. Now, if it doesn't say you put the first thing back, then you can assume you don't put it back. All right. It doesn't say I take one sock out and then put it back. It just says I randomly pick 2 socks. Okay? So I'm not putting the first one back. Does that seem to make sense now that we say it that way, or no?
Yeah, that makes sense.
Okay, good. All right, so let's see if we can answer this question. So the first time I reach into this sock drawer, I'm trying to get 2 black socks, but I'm not looking. I'm just reaching in blind. So 4 out of the 12 socks are black. But it doesn't say I put it back. So if I did get a black sock the first time, then now there's only 11 socks left in the drawer, and now only 3 of them are black. So my probability of getting a black sock now, the second pick, is only 3 out of 11. Does that make sense? Anybody having trouble with that idea, or do we feel okay about it? Lizzie Beth, are you understanding this okay?
A little.
Little, okay. We'll do the same thing again tomorrow, so you have another chance. All right, number 6. There are 8 nickels and 8 dimes in your pocket. All right, so that's 16 coins.